Here's Edx M2 January 2010, question 6 on the topic of moments and equilibrium. Take your time, pause the video and read the question carefully. Let's continue on to the next page where I've drawn the force diagram. Let's just go through this carefully. It's a uniform rod, so I've shown the weight acting at the center of the rod. Okay, its length 4 meters, so let's put that on there. That's 2 and that's 2. It's held in limiting equilibrium, so friction is mu r, F equals mu r. So I've shown that down here as 0.5 r. We know alpha, we're told tan alpha is 3/4, so we'll know sine alpha and cos alpha. Sine alpha is 3/5, cos alpha is 4/5. So everything's fairly clear, but there is a problem with this question. The question asks us to find the magnitude of the normal reaction of the ground on the rod at A, which is finding R here. Sounds straightforward enough, but the problem is, as far as the force at the other end of the rod is concerned, the force acting at B here, we don't know the direction it acts in. I've just shown it there as a force S. So the tendency or the temptation with this question is to take moments about A, because that's what we tend to do in questions like this, because there's two forces acting through A. But since we don't know the angle, the direction of S, that's going to cause us problems. So unusually in problems like this, we're going to take moments about B. Now, to take moments about B, rather than try to find all the perpendicular distances, I'm going to use the components of each of the force perpendicular to the rod. So the relevant components will be R cos alpha here, because R sine alpha will go along the rod and have no moment about B. 0.5 R, the frictional force, 0.5 R sine alpha in this direction. And again, 0.5 R cos alpha goes along the rod. And for the 20G, it'll be 20G cos alpha in this direction. So it's important to draw a good diagram, show the angles clearly. Taking moments about B then, we have, and you might like to pause the video and check this after I've written it out, R cos alpha times 4 is equal to 20G cos alpha times 2 plus 0.5 R sine alpha, sorry, I've gone a bit crooked there, times 4. So pause the video, check that you're happy about those terms in the moments equation. From now on, it's straightforward. We just put the values of cos alpha and sine alpha in. This becomes 16R over 5. This becomes 40G times 4/5. And this becomes 6R over 5 here. Collect up the R's then. We get 10R equals 160G. So R equals 16 times G, which is 157 newtons to 3 significant figures. 7 marks for that. So not much writing, but it was all about taking moments about the right place. The mark allocation, well, for stating that the frictional force is 0.5 R, we had 1 method mark for using the fact that it was limiting friction, so that's an M1. A B1 for finding sine and cos of alpha, and then a method mark and 2 accuracy marks for doing the moments equation correctly, and finally a method and an accuracy mark for finding R correctly. 1, 2, 3, 4, 5, 6, 7. That's right, that's the 7 marks. And that's January 2010, question 6, done.